Welcome back to our channel Career Prep. Today we learn about decimals. Fractions and decimals are the foundation topics in mathematics. A thorough knowledge of decimals is necessary to solve many problems in mathematics. Problems based on this topic are asked in many of the competitive exams. So please learn this topic thoroughly. Before we begin, please subscribe to our channel. Also press the bell icon to get notifications as soon as we post a new video. So let's start. So what are decimals? A decimal number is a number which has a whole number and a fractional part separated by a decimal point. The dot present between the whole number and the fractional part is called the decimal point. For example, look at this number 89.5. 89.5 is a decimal number. Here 89 is the whole number and 5 is the fractional part. And the dot between 89 and 5 is called the decimal point. Let's understand what is place value in decimals. The place value system is used to define the position of a digit in a number, which helps to determine its value. So, the position of a digit in a number helps us to determine the value of the digit. Now consider the number 456.238. The position of 6 is in ones place, which means 6 ones, that is 6. 6 ones is 6. Now the position of 5 is in the tens place, which means there are 5 tens. 5 tens means 50. The value of 5 tens is 50. The position of 4 is in hundreds place, which means there are 4 hundreds. The value of 4 hundreds is 400. So the position of the digit in a number helps us to determine the value of the digit. Now as we go left, each position becomes 10 times greater, from ones to tens to hundreds to thousands. Each position becomes 10 times greater. Now each time we move right, every position becomes 10 times smaller, from thousands to hundreds to tens to ones. Each position becomes 10 times smaller. Now what happens if we continue past the ones? What are 10 times smaller than ones? It is 1/10. 1/10 are smaller than ones. But before that, we should put a decimal point first. If a number has a decimal point, then the first digit to the right of the decimal point indicates 1/10. The second digit to the right of the decimal point indicates 1/100, and so on. Remember, as we move left from the decimal point, every number place gets 10 times bigger. As we move right from the decimal point, every number place gets 10 times smaller. Now let's learn how to read decimal numbers. Look at this number. This is read as 2 and 6 tenths, or 2.6. Here 6 is in the tens place. So this number is read as 2 and 6 tenths. Now look at this number. Here 4 is in the hundredths place. So this number is read as 82 and 94 hundredths, or 82.94. Now look at this number. Here 5 is in the thousandths place. So this number is read as 98 and 265 thousandths, or 98.265. Let's learn about rounding decimals. Rounding decimals consists of rounding a decimal number to a certain number of decimal places to save time and to help us express really long numbers in shorter terms. A rounded number has almost the same value as the original number, but it is a bit less exact. Rounding decimals is useful to estimate an answer easily and quickly. We can round decimals to the nearest wholes, tenths or hundreds when having exact values is not important. Now let's learn how to round decimal numbers. To round a number to the nearest whole, look at the tenths place. The digit to the right of the decimal point. If it is 4 or less, just remove all the digits after the decimal point. If it's 5 or greater, add 1 to the digit in the ones place and then remove all the digits after the decimal point. Let's understand this with an example. Now consider the number 7.9163. Now you have to round this decimal number to its nearest whole number. So look at the number in the tenths place. The number in the tenths place is 9. So since 9 is greater than 5, you have to add 1 to the number in the ones place. The number in the ones place is 7. So 7 plus 1 is 8. So 7.9163 rounded to the nearest whole is 8 because 9 in the tenths place is greater than 5. Hope you understood this. Now to round a number to the nearest tenth, look at the place value next to the right, that is the hundredths. If it is 4 or less, just remove all the digits to the right. If it's 5 or greater, add 1 to the digit in the tens place and then remove all the digits to the right. Let's understand this with an example. Consider the number 7.9163. Here you have to round this decimal number to the nearest tenth. So you have to look at the number in the hundredths place. The number in the hundredths place is 1. Now 1 is less than 5. So you can just remove all the digits after 9. So 7.9163 rounded to the nearest tenth is 7.9 because 9 is followed by 1 which is less than 5. Supposing instead of 1 the digit in the hundredths place was let's say 8. Then since 8 is more than 5, you have to add 1 to the number in the tenths place. Hope you understood this. To round a number to the nearest hundredth, look at the next place value to the right, the thousands this time. Now if it is 4 or less, then just remove all the digits to the right. If it's 5 or greater, then add 1 to the digit in the hundredths place and then remove all the digits to the right. Let's understand this with the example. Look at this number 7.9163. Now to round this decimal number to the nearest hundredth, you have to look at the digit in the thousandth place. Here the digit in the thousandth place is 6. 6 is greater than 5. So you have to add 1 to the number in the hundredths place. So this becomes 7.92. So 7.92 9163 rounded to the nearest hundredth is 7.92 because 1 is followed by 6 which is greater than 5. Hope you got that. Now let's learn how to compare decimals. We know that a decimal number has a whole part and a decimal part. The decimal number with the greater whole part is greater. For example, 5.4 is greater than 3.98 because 5 is greater than 3. Now, if the whole parts are equal, first convert the given decimals into like decimals and then compare the digits in the tens place. The decimal number with the greater digit in the tens place is greater. For example, 9.85 is greater than 9.65. Among these two numbers, here the whole number 9 is the same in both the numbers. So you have to consider the digit in the tens place. In the tens place, here we have 8 and here we have 6. Since 8 is greater than 6, 9.85 is greater than 9.65. Now if the digits in the tens place are equal, then compare the digits in the hundredths place. The decimal number with the greater digit in the hundredths place is greater. Look at these two numbers 0.58 and 0.55. Here the whole number is 0 in both the cases. The number in the tens place is 5 in both the cases. So you have to consider the digit in the hundredths place. Here it is 8. 8 is in the hundredths place. In this number, 5 is in the hundredths place. Since 8 is greater than 5, 0.58 is greater than 0.55. Now, if the digits in the tens and the hundredths place are same, the decimal number with the greater digit in the thousands place is greater. Look at these two numbers 51.268 and 51.265. Here the whole number 51 is the same in both the numbers. The number in the tens place is 2 in both the numbers. It's the same in both the numbers. The number in the hundredths place is 6 here. It is also 6 here. So the number in the hundredths place is also same. So now we have to look at the digit in the thousandths place. In this number, 8 is in the thousandths place. And in this number, 5 is in the thousandths place. So since 8 is greater than 5, 51.268 is greater than 51.265. Let's understand the concept of comparing decimals better with an example. Look at these two numbers 23.789 and 23.759. Here the digits before the decimal point are equal. That is, it is 23 in both the decimal numbers. So move on to the tens digit to compare. Here in the tens place in both the numbers it is 7. 7 is in the tens place in both the numbers. So both of them are equal. Now move on to the next digit to the right of the tens digit, that is the hundredth digit. Now in 23.789, the digit in the hundredths place is 8. In 23.759, the digit in the hundredths place is 5. So, since 8 is greater than 5, we can say that 23.789 is greater than 23.759. Let's learn about the different types of decimals. There are two types of decimals, terminating decimals and non-terminating decimals. What are terminating decimals? Terminating decimals have a finite number of digits after the decimal point. This means that there is a definite number of digits after the decimal point. These are also called exact decimal numbers, as the digits after the decimal point are countable. Look at this number 98.678. 98.678 is a terminating decimal because there's a definite number of digits after the decimal point. That is, there are 3 digits after the decimal point. Now look at this number 29.5. This is also a terminating decimal because there is only one digit after the decimal point. The number of digits after the decimal point are countable. So both these numbers are terminating decimals. So what are non-terminating decimal numbers? Non-terminating decimal numbers are decimals that have an infinite number of digits after the decimal point. They are non-terminating decimals that repeat endlessly. So non-terminating decimal numbers are decimals that do not have a definite number of digits after the decimal point. The numbers keep on repeating endlessly. There is no end to the number of digits after the decimal point. Non-terminating decimal numbers are further divided into two types: recurring decimal numbers and non-recurring decimal numbers. Recurring decimal numbers are decimal numbers that have an infinite number of digits after the decimal point, but these digits are repeated at regular intervals. Look at this number 4.78, 78, 78, and so on. This is a recurring decimal number because there is an indefinite number of digits after the decimal point. Moreover, the digit 7, 8 is repeated at regular intervals: 7, 8, 7, 8, 7, 8, and so on. So since this decimal number has an infinite number of digits after the decimal point and the digits are repeated at regular intervals, this number is a recurring decimal number. Non-recurring decimal numbers are decimal numbers that are non-terminating and non-repeating. They not only have an infinite number of digits after the decimal point, but their decimal place digits don't follow a specific order. So in non-recurring decimal numbers, there is an indefinite number of digits after the decimal point, and the decimal place digits do not follow a specific order. It's just a random sequence of digits after the decimal point. Look at this number 56.78965 and so on. Here, after the decimal point, there is an infinite number of digits. Also, these digits do not follow any specific order. It is just a random sequence of numbers. So 56.78965 and so on is a non-recurring decimal numbers. Now let's learn about like and unlike decimals. Decimals having the same number of decimal places are known as like decimals. That is, decimals having the same number of digits on the right side of the decimal point are known as like decimals. Otherwise, the decimals are unlike decimals. For example, 5.25, 15.04, 273.89 are all like decimals, as there are same number of digits after the decimal point. Each of these numbers has 2 digits after the decimal point. So these three numbers are like decimals. Now look at these numbers: 9.5, 18.235, 20.0254. These three numbers are unlike decimals because they have different number of digits after the decimal point. 9.5 has one digit after the decimal point. 18.235 has three digits after the decimal point. 20.0254 has four digits after the decimal point. So these three numbers are unlike decimals because they have different number of digits after the decimal point. So like decimals have the same number of digits after the decimal point. Unlike decimals have different number of digits after the decimal point. It's important to note that putting zeros on the right side of the extreme right digit of the decimal part of a number does not alter the value of the number. Thus, unlike decimals can be converted into like decimals by putting the required number of zeros on the right side of the extreme right digit in the decimal part. This means that unlike decimals can be converted into like decimals by putting the required number of zeros on the right side of the last digit of the decimal number. For example, 7.4, 15.35, 49.105 are unlike decimals because 7.4 has one digit after the decimal point, 15.35 has two digits after the decimal point, and 49.105 has three digits after the decimal point. Now these unlike decimals can be rewritten as like decimals by adding zeros at uh, after the last digit of the number. First, we have to consider uh, the number that has more number of decimal places, that is the number which has more number of digits after the decimal point. Here it is 49.105. This number has three digits after the decimal point. So now to make 7.4 as a like decimal of 49.105, this 7.4 has to have three digits after the decimal point. So we have to add two zeros after 4. So we get 7.400. Now 14.35 has two digits after the decimal point. So to make it three digits after the decimal point, we have to add a zero after 5. So 15.35 can be written as 15.350. So now 7.400, 15.350 and 49.105 are all like decimals because they have three digits after the decimal point. Let's learn about the arithmetic operations on decimals. First, we'll learn about addition and subtraction of decimals. To add or subtract the decimals, you have to follow these steps. First, you have to convert the given decimals to like decimals. Next, you have to write the decimals in the columns with their decimal points directly below each other so that the tenths come under the tenths, the hundredths come under the hundredths, and so on. Next, add or subtract in the same way as you would add or subtract whole numbers. Place the decimal point in the answer directly below the other decimal points. Now let's understand this with examples. First, let's understand addition of decimals. Add 51.37 and 24.5. Now these two numbers are unlike decimals because 51.37 has two digits after the decimal point and 24.5 has only one digit after the decimal point. So now to make 24.5 as the like decimal of 51.37, add a 0 after 5. So 24.5 can be written as 24.50. Now write the numbers in the column in such that the decimal points are directly below each other. So write 51.37 and 24.50 in such a way that the decimal points are below each other, the tens digits are below each other, and the hundredths digit are below each other. Now just add these two numbers. You will get 7587. Now put the decimal point in the answer directly below this decimal point. So the final answer will be 75.87. Now let's understand subtraction of decimals. Subtract 5.1 and 2.37. Here also these two numbers are unlike decimals because they have different number of digits after the decimal points. So to make 5.1 as the like decimal of 2.37, you have to add a 0 after 1. So 5.1 is written as 5.10. Now write 5.10 and 2.37 in such a way that the decimal points are below one another, the tens place digits are below one another, and the digit in the hundredths place are below one another. Now subtract these two numbers as usual. So when you subtract 2.37 from 5.10, you will get uh, 2.73 because you have to add the decimal point. You have to place the decimal point in this answer directly below the other decimal points. So the final answer is 2.73. Hope you have understood the addition and subtraction of decimals. Now let's understand multiplication of decimals. First, we'll learn about multiplication of decimal numbers by 10, 100, 1000, etc. You have to follow these rules to multiply a decimal by 10, 100, 1000, etc. When you multiply a decimal number by 10, the decimal point is shifted to the right by one place. For example, when you multiply 4.03 with 10, the decimal number has to shift to the right by one place. So the answer will be 40.30. When you multiply a decimal number by 100, the decimal point is shifted to the right by two places. For example, 4.03 multiplied by 100, the decimal point has to shift to the right by two places. So the decimal point has to shift to the right by two places, and the answer will be 403.00, which is nothing but 403. Now when you multiply a decimal number by 1000, the decimal point is shifted to the right by three places. So when 4.03 is multiplied by 1000, the decimal point has to shift to the right by three places, 1, 2 and 3. So the answer will be 4030.00, which is nothing but 4030. Let's learn multiplication of a decimal number by a whole number. To multiply a decimal number by a whole number, you have to follow these steps. Multiply the decimal number without the decimal point and the given whole number. After finding the product, count the number of digits present after the decimal point in the given decimal number. Then mark the decimal point in the product such that it has the same number of digits after the decimal point as the given decimal number. Now let's understand this with an example. We'll multiply the decimal number 741.35 with the whole number 5. So first you have to multiply this decimal number as though there is no decimal point and the given whole number. So 741.35 will be considered as 74135. So 74135 multiplied by 5 will give the product 370675. Now after finding the product, count the number of digits present after the decimal point in the decimal number. So here after the decimal point there are 2 digits. So now in the product you have to mark the decimal point such that there are 2 digits after the decimal point. So the product will be written as 3706.75. Now this answer also has 2 digits after the decimal point, just like the given decimal number 741.35. So the final answer is 3706.75. Let's learn about multiplication of a decimal number by another decimal number. To multiply a decimal number by another decimal number, you have to follow these steps. Multiply the two numbers without the decimal point, just like whole numbers. Then mark the decimal point in the product such that it has the same number of digits after the decimal point as the sum of the number of decimal places of the given decimal numbers. Let's understand this with an example. Let's multiply the decimal number 74.35 with another decimal number 3.6. First, we have to multiply these two numbers as though they are whole numbers. We have to ignore the decimal point. So, multiply 7435 with 36. You will get the product 267660. Now, you have to count how many number of digits are there after the decimal point in these two decimal numbers. So 74.35 has 2 digits after the decimal point. 3.6 has 1 digit after the decimal point. So 2 digits plus 1 digit is 3 digits. So now mark the decimal point in the product such that there are 3 digits after the decimal point. So 267660 can be written as 267.660. So now this answer also has 3 decimal places. Now let's learn about the division of decimals. Division of decimal numbers by 10, 100, 1000, etc. You have to follow these rules to divide a decimal number by 10, 100, 1000, etc. When you divide a decimal number by 10, the decimal point is shifted to the left by 1 place. For example, when you divide 4.03 by 10, the decimal point is shifted to the left by 1 place in the answer. So, the answer will be 0.403. When you divide a decimal number by 100, the decimal point is shifted to the left by 2 places. So, when you divide 4.03 by 100, the decimal point has to shift 2 places to the left in the answer. So, the answer will be 0.0403. When you divide a decimal number by 1000, the decimal point is shifted to the left by 3 places. So, when you divide 4.03 by 1000, the decimal point has to shift by 3 places to the left, 1, 2 and 3 places in the answer. So, the answer will be 0.00403. Now let's learn about division of a decimal number by a whole number. To multiply a decimal number by a whole number, you have to follow these steps. Division is performed in the same way as in the whole numbers. First, divide the two numbers ignoring the decimal point. Then, place the decimal point in the quotient in the same position as in the dividend. Let's understand this with an example. Let's divide this decimal number 741.35 with a whole number 5. So first you have to divide these 741.35 by 5 as though they are both are whole numbers. That is, you have to ignore the decimal point in the decimal number. So divide 74135 by 5. You will get the quotient as 14827. Now count the number of digits after the decimal point in the decimal number 741.35. Here there are 2 digits after the decimal point. So place the decimal point in the quotient such that the quotient also has 2 digits after the decimal point. So 14827 is written as 148.27. So 741.35 divided by 5 is 148.27. Now let's learn about division of decimal number by another decimal number. To divide a decimal number by another decimal number, you have to follow these steps. Multiply the dividend and the divisor by either 10, 100, 1000, etc. to convert the divisor into a whole number. Next, ignoring the decimal point of the dividend, divide the new dividend by the whole number acquired in the previous step. Then place the decimal point in the quotient in the same position as in the dividend. Let's understand this with an example. Divide 3.64 by 1.4. Here 3.64 is the dividend, 1.4 is the divisor. You have to convert the divisor into a whole number. That is, you have to convert 1.4 into a whole number. To do that, you have to multiply 1.4 by 10. 1.4 multiplied by 10 is 14, a whole number. But since you multiplied 1.4 with 10, you have to multiply 3.64 also with 10. So 3.64 multiplied by 10 will give you 36.4. Now you have 36.4 as the dividend and 14 as the divisor. So you have to divide 36.4 by 14. To do that, first you have to ignore the decimal point in 36.4. So now you have to divide 364 by 14. When you divide 364 by 14, you will get the quotient as 26. Finally, count the number of digits after the decimal point in 36.4. In 36.4, there is one digit after the decimal point. So place the decimal point in the quotient such that the quotient also has one digit after the decimal point. So 26 is written as 2.6. So the final answer is 2.6. When 3.64 is divided by 1.4, you get the quotient as 2.6. Now let's learn how to convert decimals to fractions. To convert a decimal to a fraction, first write just the decimal number without the decimal point as the numerator. Then write its place value as the denominator. Let's understand this with an example. Let's convert the decimal 0.09 to its fraction. Now, first you have to write just the decimal number without the decimal point as the numerator. So write 9 as the numerator of the fraction. Then write its place value as the denominator. Here 0.09 is 9 hundredths. So write 100 as the denominator. So 0.09 can be converted to its fraction and written as 9 by 100. 9 in the numerator and 100 in the denominator. You can also remember how to convert decimals to fractions as follows. First, just write the decimal number without the decimal point as the numerator. So, 9 is written in the numerator. Next, count the number of digits after the decimal point in the decimal number. Here, there are 2 digits after the decimal point. So you have to write 100 in the denominator. Supposing there are 3 digits after the decimal point, then you have to write 1000 in the denominator. Hope you have understood this. Now let's understand how to convert decimals to mixed fractions. Decimals with values greater than 1 can be written as mixed fraction by following these steps. First, consider the whole number part and the decimal part in the given decimal number separately. Write the decimal part in the fractional form by writing just the decimal number without the decimal point as the numerator. Then write its place value as the denominator. Simplify the fraction obtained. Finally, attach the whole number part of the original number with the fraction obtained in the previous step. That would be the answer. Now let's understand this with an example. Convert 3.75 into a mixed fraction. First, you have to consider 3 and 0.75 as separate entities. The whole number 3 and the decimal part 0.75 as separate entities. Now 0.75 can be written as 75 by 100. First you have to uh, write just the decimal number without the decimal point as the numerator. So 75 is written in the numerator. Now after the decimal point there are 2 digits. So write 100 in the denominator. So 0.75 can be written as 75 by 100. Now simplify 75 by 100. When you simplify 75 by 100, you will get 3 by 4. Now attach the whole number 3 to 3 by 4. So finally you will get the answer as 3 by 4. Let's learn about recurring decimals and fractions. A recurring decimal is a decimal number in which a digit or group of digits repeats forever. Look at these examples: 0.33333 and so on. Here the 3 repeats forever. Look at this number: 0.142857, 142857 and so on. Here the group of digits 142857 repeats forever. In this number 0.1283333 and so on, the first 3 digits 1 to 8 are written as it is and 3 keeps repeating. So these 3 numbers are called recurring decimals since they have a digit or group of digits that repeat forever. Now the recurring part is usually denoted by placing a line on the first repeating digits. So 0.333 and so on is written as 0.3 and a line is placed on 3. Here 3 is the repeating digit. So the line is placed on the first repeating digit 3. In this example 0.142857, 142857 repeats forever. So the line is placed over the that group of digits. So it is written as 0.142857. with a line above the group of digits that is repeating. Now look at this number 0.12833333 and so on. Here the repeating number is 3. So 0.128 is written as it is, and the line is placed on the first repeating digit, that is 3. So 0.1283333 and so on is written as 0.1283 with a line on the first repeating digit 3. Hope you have understood this. Now let's learn how to convert a recurring decimal into a fraction. The first type, all the digits after the decimal point are recurring. Then for the numerator, write the decimal part without the decimal point. And for the denominator, write as many 9s as there are repeating digits. Let's understand this with an example. 0.387. Here the digits 387 are recurring because a line is placed over this group of digits. So for the numerator, write the decimal part without the decimal point. So 387 is written as the numerator. Now count how many repeating digits are there in this recurring decimal. Here there are 3 repeating digits. So you have to write 3 nines in the denominator. That is 999. So now you have the fraction 387 by 999. Now let's look at another example, 7.17. Here 7 is a whole number and that remains unchanged. And 17 is the recurring part because a line is placed over 17. So 7 is written as it is. Now for the numerator, write the decimal part without the decimal point. So write 17 as the numerator. For the denominator, count the number of repeating digits. Here there are two repeating digits, 1 and 7. So write 2 nines in the denominator, that is 99. So the fraction is 17 by 99. 7 is the whole part and 17 by 99 is the fractional part. So 7.17 where 17 is repeating can be written as the fraction 17 by 99. Now let's learn how to convert a recurring decimal where only some of the digits are recurring into a fraction. In such cases, for the numerator, write the decimal part without the decimal point and subtract the non-repeating part from it. For the denominator, write as many nines as there are repeating digits and follow it with as many zeros as there are non-repeating digits. Let's understand this with an example. Look at this recurring decimal 1.2345. Here 1 is the whole number and it remains unchanged. 2 is the non-repeating digit. Only 3, 4, 5 are the repeating digits since a line is written above 3, 4, 5. So 1 is the whole number, 2 is the non-repeating digit, 3, 4, 5 are the repeating digits. So write 1 as it is. Now for the numerator, write the decimal part without the decimal point and subtract the non-repeating part from it. So write the decimal part without the decimal point. So write 2, 3, 4, 5 in the numerator. Then subtract the non-repeating part from it. Here the non-repeating part is 2. So subtract 2 from 2, 3, 4, 5. You will get 2, 3, 4, 3 in the numerator. Now for the denominator, write as many nines as there are repeating digits. Here there are 3 repeating digits. So write 999 in the denominator. Then follow it with as many zeros as there are non-repeating digits. Here there is only one non-repeating digit, 2. So there's only one non-repeating digit. So write only 10 after 999. So now you have 9990 in the denominator and 2343 in the numerator. Now when you add 1 with this fraction 2343 by 9990, you'll get the answer as 4111 by 3330. Viewers, hope you have understood the concept of decimals. Fractions and decimals are simple and easy concepts, but they are extremely useful in solving many problems under various topics. So be very clear about the concept. We have uploaded a video on simplification. Please do watch that video also. If you have liked this video, please like, subscribe and share this video. Thank you.